Now that the HTML for our to-do list app is ready, the time has come for us to code the JavaScript. To do that, I want you to go back into your project folder and then click script.js, and this is where the magic will happen. Okay, so the first thing we want to do is we want to get references to our elements in our JavaScript. Remember, our front end has various elements, so it has the input field, it has the button, and it has an invisible list over here that is invisible because we haven't added any items to it. So what we want to do is we want to add a reference to this input, to this button, to the list, to the invisible screen reader, live region, everything. And I'm going to start by getting to do input. So we're going to start by getting a reference to this element. And to do that, I'm going to go const. Const is a keyword that references a constant, which means that you're not allowed to override it. And we usually use this for element references because they're unlikely to change during the life of the program. So what I'm going to do is I'm going to do document.querySelector, and then I'm going to do quotation marks, and I'm going to say hashtag or £sign to do, because this is the ID of our input called to do. So we're fetching the inputs. Okay. Now I'm going to put a semicolon, and the next element I'm going to get is the list. So I'm going to do const again. And what we want to fetch is we want to fetch the now empty list because we want to populate it with list items. So we're going to get the ID of list, which is list, and we're going to do list, and we're going to do the same thing. Document.querySelector hashtag list. Okay, and I'm going to fetch a couple of more elements, and I'm going to write them down and I'm going to explain them to you. Okay, we fetched all the elements that we needed in order to write our program. We have the form, we have the invisible area live region, and we have the heading. We are going to need the heading because we want to focus it later on. You'll see. Let's start writing the meat of our function. The first thing we want to do is add some sort of method to the form. So we're going to say to do form dot add event listener submit, and then we're going to do comma function event, and then what we're going to do then is open quotation marks. Okay, so what's happening now is we're saying, hey, whenever the form submits, I want you to execute whatever is it in that block over here. So if we say, for example, on submit console log, ducks, that's going to say whenever the form submits, output ducks in the console log. Let's try to test our masterpiece. I'm going to go ahead and open the console. Okay, right now it's empty, but if I submit, okay, I actually have to add something. If I submit, I get ducks. However, see how the page refreshed and I get an error? That's because whenever a form submits, it tries to find some sort of a server-side processing file. It couldn't find it in our case because our form has the action of the index.html, which has no server-side language. So what we want to do is we want to prevent the natural instinct of the form whenever we submit it. So what we want to do is we want to get the event object here, and we want to say event prevent default. So now, right now, let's test it again. So right now, if we say fade chicken, and we open up our console and we click add, the form isn't submitted and we still get ducks in our console log, which means that our program is working. Every time I use add event listener, I usually output something funny in the console log to make sure that I am referencing the correct element, that I'm using the correct event listener. I can't tell you how many times I have added add event handler instead of event listener, because this is called an event handler actually, but the name is event listener. That even happened to me during a live coding interview. I kid you not. I wrote add event handler and then I was wondering for like 5 minutes why it wasn't working, but it was embarrassing. Anyways, so now that we have our meat of the program working, let's make it do some real stuff. So what we want to do first is we want to get the value of our input. So whenever the value is, we want to output it. Let's say Right now the value is feed chicken, so what we want to do is we want to get the value. So I'm going to say let task. What let is, it is the beginning of a variable, and the reason you can use const, which actually const isn't a variable, it's a constant, but it's sort of like a variable as well, because you know it references an element in memory, but it can be changed. So the two methods are var and let. We're going to use let because we want the scope to be very narrow. It's always better to use let if you want to minimize the scope. So we're going to say let task. We're going to do to do input dot value. Whoops, value. Okay. And you might be wondering, where are we getting the to do input? We're getting it from the top where we already referenced it. Okay. So, and let's try to see if it's working. We're going to say console log task. And over here, I'm going to say, I'm going to refresh. And then let's say chicken console add, and then whatever we write here, it's going to be outputted in the console. This means that our program is working correctly. So we just don't want to output stuff in the console forever, because that will make it like the most boring program ever. So what we want to do then is we want to add some functions in the body to output. So the first thing we want to do is we want, whenever a person enters a task and we click add, we want the task to be outputted in our list element, which is over here. See, we want to populate this list element with some text. And to do that, what we got to do is we have to add a function down here. So our first function is going to be add task to DOM. And we're going to make it very simple at first. So let's try to do that. Okay, let's start coding. So the name of our task is going to be add task to DOM. So we're going to write down that. So we're going to say function add task to DOM. And DOM stands for document object model. And the task is going to be the name of our task. So the first thing we want to do is we want to add a list item. So we want to add this element into our list, into our UL. Okay, UL. So to do that, what we got to do is first we have to create the element. So we're going to say let lig, and we're going to say document dot create element, and in the quotation mark is going to be the name of the tag, which is li, list item. And then the next variable we're going to need is the text. So we're going to say let text is, this is actually going to be the task. So normally you would do a new text node and then the name of the text, but this is going to be our task. So what we got to do then is we can just go ahead and append. So what we can do is li dot, actually we know we need to create a new text node. I got confused. Okay, so let, so for example, task text is going to be document dot create text node. So the JavaScript API for creating elements is, I don't like it. It's very verbose and it's just plain confusing. Like you have to create a text node and then add it into the element you referenced above. It's a whole thing. I don't like it, but yeah, live with it. It's the only thing I don't like with vanilla JavaScript. The rest of it's fine. Okay, and then we have to, what we did here is we added the task, which was going to be, for example, feed chicken or give dragons a haircut. We have our task and we added it in a text node. So now we want this text node to be inside our list element. And to do that, we do li dot append child, and the child is going to be task text. Okay, now that our li is complete, we want to append it. Remember, we want to append it to our list over here. And to do that, what we got to do is we have to reference the list, which we already did at the top, which has the constant of list. So we're going to say list dot append child, and we're going to say li. Okay. Now let's, right now it's not going to do anything because we haven't referenced the function inside our body. So when when we go inside our event listener, what we got to do is add task to DOM function. And the task argument here, we're fetching it from above. Remember, this variable here holds whatever value is contained in our input over here. So let's try to do that. I'm going to say task. Now let's test it out and see if it works. Okay, let's do feed chicken. There we go. It's working. Let's say, for example, wash dragons. Make sure you misspell it. Okay, so we can add as many tasks as we want and it's going to work. So we have a great system here and it's working correctly. And if we go to expand element, you can see how the LIs are being populated. And if we refresh the page, the list here is empty. So, okay, see, the list is empty because it's not being done anything with. So if we go back into our program is working great. And the next task we want to do is we have, every time we add a task, the task value remains. So we have to actually go there and delete it, and it's not very user friendly. So what we want to do is we want, whenever we submit, we want the value of the input to automatically disappear. And to do that, we're going to add another function and we're going to say remove, we're going to name it remove value. And it's going to be very straightforward. We're going to say remove value input. This will reference the input element, and we're simply going to say input dot value blank. So again, copying the name of the function, referencing. It's very important to stack your functions in a way that expect them to go. So for example, don't remove value before you added the task to the task list, otherwise it will just all hell break loose. Okay, so now we want to reference the input, and we did that with to do input over here with the constant. So let's refresh and let's say, okay, it's working great. Now that this is done, let's add another function. What we want to do later on, after all that is done, is we want to alert the screen reader that a task has been added. Remember, we're adding an accessible JavaScript program. And whenever you add a task, whenever you say, for example, LOL, if you are cited, you see that the task has been added to the list. But if you're not cited and you're using a screen reader, the screen reader is not going to just automatically tell you that a task has been added. We have to do that manually. And if you remember from our previous tutorial, we added this div with the ID of SC feedback. So we want to start populating this area here. And to do that, we're going to add yet another function. And the name of the function is going to be screen reader feedback. So let's try to do that. And this function is going to be very simple. It's going to say function screen reader feedback, and then it's going to take two arguments. The first is going to be the name of the task, for example, wash dishes, wash dragons, whatever. And the second argument is going to be not mandatory, it's going to be optional, and it's going to be the name of the feedback. So I'm going to set the default, and by default it's going to say added. So what we got to do there is we have to reference our life region. Remember, whenever you attach area life attribute to an element, it's called a life region. So the name of our life region's ID is SC underscore feedback, which, as you remember, we referenced above. So we copy SC feedback, we paste it here, and then we add text content. And over here, I'm going to add some object literals. I'm going to say $task space, and then I'm going to say $ curly braces feedback and a dot. If you aren't familiar with object literals, they allow you to write text content, if you like, and interpolate it with variables without having to constantly break from the string literal with plus signs. So if you're familiar with, in the past, we would write document.write and we would do something like this. For example, my name is, and then we would break out of the quotation marks and we would write a plus sign that says, and we'll reference a variable. But let's say if you have one variable, that's fine. But if you have many variables, you have to constantly, go out and go inside the quotation marks again, look, and my age is, and again, breaking up. It's just, it's more difficult to write, whereas with template literals, with template literals, it is much easier. Okay, so now that this is done, let's add our function here, and let's add task, and we don't need to add a second argument because it is by default added. Let's test to see if our efforts have been in vain or not. Feed chicken, add, and here we have the list outputting list items, and then we also have feed chicken added. This is the live region we talked about. Now it's being populated. So what's that gonna happen is if you're using a screen reader and you add something, for example, feed chicken again, feed chicken added is going to be announced by the screen reader. So now that this is done, let's see what else we want our program to do. So one thing that we're missing is whenever we add a task, we have no way of deleting the task, and we have no way of checking the task that it was completed successfully. Because what we're doing right now is we're just creating a list element or a list item without a button or without a checkbox. So to do that, we need to actually create those elements, and we need to add them as children of this li element. But since JavaScript's API for creating elements is very verbose, and frankly it's not a good one, what we gotta do is just copy this 3 more times, because we need to create 3 elements at once. Actually, yeah, 3 elements at once. We need to create an li, and the li needs to have children of label, input type checkbox, and a button. So that's actually, we need to create 3 more elements. So this is what's gonna happen. We have to copy and paste the code all the time. But since we're good programmers, we're going to abstract this by creating a helper class or helper function. What we're gonna do now is create a new function. So what we're gonna do is do function create element, and the create element will take 4 arguments: tag name, text node, parent, and attribute, which is going to be an optional argument. So the first thing we want to do is create our node, which is going to be node equals document dot create element tag name. So this is going to be the name of our element, and here we can add button, list item, label, whatever we want. Then we want to add an if statement saying if the text node isn't null, then append it to the element. So let custom text node equals document dot create text node, and we're going to reference the text node that we passed. So what's that gonna say is this is going to be the text node of our element, and text node, also known as inner HTML, this is going to be the text in between the tags. For example, we have a list element like this. Text node is going to be the text over here. See, the text here, text node here. Okay, and then we want to append this. Okay, so the attribute argument is going to be an array, and then we're going to say 0, and then the next one is going to be 1. So the way set attribute works is it works like this. Set attribute, you have 2 arguments. The first is the name of the attribute, and the second is the value. So for example, if I have an input and I want to add type, we add type, and the second is going to be, for example, checkbox or text, or let's say I want to add a class to an element. The first argument of the set attribute function is going to be class, and the second one is going to be the name of the class, let's say ducks. Okay, this is what set attribute, and we want this argument to be an array, and we're passing it off for the first index of the array is going to be the name of the attribute, and the second is going to be the value of the attribute. Okay, hope that makes sense. And now we want to add another another check, which is going to be if an attribute exists, then add the attribute to our element. Okay, let me see if that's correct. Okay, actually made a mistake. This was supposed to go here. Okay, and we want to append the text node to our node. Okay, that should be correct. And the last, okay, let me see. Yeah, we want to close off the if statements. Okay, there are two different if statements. They're not nested if statements. And then what we want to do is say parent. We're referencing this argument here. Dot append child node. Whenever you're working with the JavaScript element API, you always append the child to something, always, even if it is the HTML element. And now we want to return the node. What return the node is going to make us do is we can do something like li create element. You know, we're going to have our arguments here, and then we can use this li and do something like, for example, class name. We can manipulate it any way we want, but to do that, we have to return it, okay? If we don't return it, this function is still going to work, but it won't give us a reference to the element we just created. So we won't be able to add any methods to it, like class name, class list, etc. Okay, now that this function is complete, what we're gonna do is we have to add the task to our DOM. And to do that, what we gotta do is actually go inside our add to task DOM and actually delete what we just added. So the first variable is going to be new ID. So we have to give an ID to each. We're going to give an ID to each input we create. So remember, the input we create is going to be a checkbox. And we're just going to say generate ID. And now let's create this function. This function is going to go down here, and we're going to say generate ID. And this is just going to be, you know, pretty straightforward. We want every single input element to have a unique ID. So we need to create a prefix, and the prefix is going to be task num underscore, and then we want to reference tasks. So we want the number of the ID to go right behind task num, but we want to get unique ID, and to do that, we're going to count how many tasks we have. So to do that, what we're going to do is just do document.query selector O, and this will give us a list of elements that are inside our list. So this is the number of tasks. So for example, right now we have 0 tasks, but if we add a task, right now we have 1 task, and this will reference 1 task, but it will just reference the nodes. And then what we're going to do is we're going to say if tasks dot length. So we're counting how many tasks are in the document by referencing this variable. So we're saying if there are no tasks in our document, so if this is the first task, then we want to return this. So we want to say task num 0, and then we're going to return the ID prefix and the task num. So if, for example, now they're 1, now there's, for example, if there's like 2 tasks, oops. All right, that's right, it's not adding because we deleted our program. If there are 2 tasks, this will say 2, okay. And this is how you create a unique ID. So if we go back into our task over here, okay, let task to DOM. Okay, let's try to add some meat into this function. We have to start creating our tasks. So we're going to say let task item create element. So we're referencing the function beneath it, and we're going to pass our arguments. So the first element we want to create is a lim, which is the list item. The text node, we want it to be empty. Why? Because we want to add our checkbox inside a label. And we do that because so that whenever a user focuses the checkbox, the screen readers will announce the name of the task. And then we want the task item to be a child of the list. So the parent is going to be list. And list, remember, we referenced our elements that we're working on over here. And list is reference at the top, and it's this element over here. Okay, let me see where I was. Okay, list. And then we want to add an attribute. Remember how we talked about this array over here, how we would add attributes to our elements, and how this array takes 2 arguments. So the first argument is going to be class, and the second one is going to be task, so that we want each list item to have the class of task. Okay, now we're going to do the checkbox. I'm going to say create element. Now the tag name is going to be input, and since checkboxes have no text, we're just going to say no, not true. And then we're going to say task item. This, we want the checkbox, whoops, we want the checkbox to be a child of our label. This is why we're having it as a child of the task item, not as a child of the list. And then we want the checkbox to be actually checkbox. So we're going to say type checkbox. Okay. And now we need to create the label and the delete button. So I'm going to do that real quick and I'm going to explain it to you. Okay, so I added the label and the delete button, and I made the delete button not to be a child of the label, but a child of the li, which is over here. And the label is going to be a child of the li as well. And the label is going to be a sibling of the button. So I know it sounds confusing, but it's going to make sense when we actually generate it. So add task to DOM is going to be the same. So I'm going to take 1 argument, which is the name of the task. Now let's try to see if it's working. Okay, let's add task wash dishes. Oh, there we go. We have our checkbox that we can check in and check. We have the task and we have the delete task button. And if we add another task, and then we have it again. Now it looks ugly because it's not styled, but the beauty of this is that it's completely keyboard operable. So if I tap on the input, tap on the button, and then go down, I can select all those elements. And remember, this is something that I've seen in so many to-do list apps, is that they're not accessible. They're using a span, for example, for the checkbox, or they're using a div for the button. It's just really bad. And if I go to the checkbox and I click spacebar, I can check in and check, or, you know, it's just so accessible. And we created this magic using add to task DOM and create element. So instead of copying and pasting, we managed to abstract it, and inside our submit form event listener, we're only using a handful of functions. So right now you're probably thinking, Stephanie, why did you create all those functions and added more weight to your program instead of just inlining the functions bodies inside our main function or our event listener? The reason I did that is because of readability. There is a quote I read a while ago that said, programs are meant to be read by humans and sometimes computers. If you have no idea what this code is supposed to be and you open this code anew and you start reading, it makes sense. So in a way, the code is self-documenting. Like you can see, okay, to do form, this is the form. This is the form over here. Add event listener on submit. Okay, so something is happening when the submit, and then you see the names of the functions outlining what actions are taken by this event listener. So add task to DOM, remove value, and screen reader feedback. It is very easy to read because we created functions with accessible names. If we had just copied and pasted all of this inside our function, our main function here, it would be very difficult to read. And yes, it might have, this program might have 0.1 millisecond delay because of the extra code, but it totally makes sense if it's easier to read, and this is very important when you're programming. So right now our program is very successful in outputting our tasks. I added some CSS to make the program a bit nicer. What I also did is I enlarged the input and the submit button, because WCAG tells you that you must have elements that are at least 44 by 44 in pixels in height and width, so that users with phones or those suffering with Parkinson's will be able to select them via touch. So this is what I did. Now, what we want to do next is we want to replace the delete task for the task to be deleted. And this is going to be a bit tricky, but just stay with me. The first thing we want to do is we want to add an event listener to this delete button. The problem is we don't know how many tasks there are going to be in our task list, okay? So there could be 1, there could be 500, but we have a solution in mind. So let's start coding. First, I'm going to add a function called hasClassName. And what this function is going to do, it's going to check if a specific element has a specific class. And I'm going to pass 2 arguments. First is going to be element and the name. Next is going to be class name. And then I'm going just to add element dot class list dot contains class name. And the reason we're not just doing element dot class, something like this, because one element can have multiple classes, whereas one element can only have one ID. This is why we must see if a specific class name exists within a list of classes. And to do that, we use the class list property, okay? So we're saying if element.classList contains class name, which is going to be the second argument in our parameter list, then we want to return true. And then if it's false, we just want to return false. Okay, that's simple enough. Let's hope that we did not screw up this program. And the next thing we want to do is we want to capture those delete buttons, okay? So what we're going to do is we're going to work with something called JavaScript bubbling. Now, if you don't know what JavaScript bubbling is, it's something that looks very complicated. Basically what it is, inside our HTML, the way that HTML works is if I click somewhere on the page, for example, let's say that I click the submit button. The submit button gets the click event, but then the click event just goes up the DOM tree. And so this div, which is a parent of the submit button, gets the click event too. Then its parent, which is the form, gets the click event. Then its parent, which is this div, gets the click event, this, until it goes all the way to the HTML element. This is what bubbling is. If you need more information, there is a great tutorial by the Net Ninja. He explains it even better than I can. So the reason we're doing bubbling instead of just capturing all of the submit button, all the delete buttons, excuse me, is because we don't know how many delete buttons are going to be on the page. And when the page initially loads, there are no delete buttons. So if we say all buttons, event listener, on click, delete, this is not going to work because on page load, there are no delete buttons since no task has yet been added. So what we're going to do now is we're going to add an event listener for our list. So we're going to add an event listener for our list right here that holds our task. So this is has the ID of list, and we have already captured this in our constant right here. So we're going to do list dot add event listener click, and then we're going to say function event object, and then we're going to open it up, and inside here we have to check if the user has clicked on the delete button. So if has class name event.target, event.target holds the element that has been clicked. In this case, we're checking if the element that has been clicked is the delete button. And remember, we're using the hasClassName function we defined earlier, and it has 2 arguments. The first is the element, and the second is the class name. The class name of our delete buttons is delete task. So if that's true, then we want to define some new constants. So we're going to define a constant of li, which is what we're trying to do is we're trying to find the parent of this button. If we look at our markup here when it's generated, see, our button lives within an li element, and the li is a child of the ul. So what we're trying to do is, okay, whenever somebody clicks this element, if they click the button, I want you to find their parent, which is the li. And the reason we can't just call the li in a query selector is because there could be so many li's on the page that we want to specifically call the parent of the specific button that has been clicked. Okay. So in this case, we do event dot target, and then we want to invoke the closest method, and then we want to say li. What the closest method is, it finds the closest parent of a specific element. So we want to find the closest parent to this delete button, which is going to be its parent, its li. Okay, now that that's done, we also want to make another constant, which is going to be task name. This is important because we want to get the text of our task name, like wash dishes, feed dragons, whatever. So now here we're going to find previous element sibling. So this is going to be the task name. And actually, this is the element, and we need the text content. So we're going to say text content. Okay. Afterwards, now that we have here these things, let's test them out to see if they work. Let's do control log li, and what I'm going to do next is I'm going to add a task. Then I'm going to open my console and click delete task. Okay, awesome. So right now when we click our delete task, it's giving us back the parent, the li parent. So if we say console log li, it's going to show. And to prove that it's actually the parent, what we're going to say is li style display, no, style, let's try style color red. Okay, let's see if that works. Okay, there we go. See, if I have a bunch of tasks, okay, and I click, only their parent becomes red, which is great, which is what we wanted. We want to control only their parents. So now that that's done, what we want to do next is we want to actually create some more functions. And the first function we want to create is delete task. And this is going to be very straightforward. It's going to say delete task. We're going to give it an argument of the target, and we're going to say list remove child the target. Okay, remove child is part of the JavaScript element API, and what that says is it removes, pretty much it removes the child and yourself at the same time. So what we're going to do now is we're going to say delete task li. So what's that's going to happen is the li is going to destroy itself. If that makes sense. Okay, let's see if that actually works. Okay, we're gonna say test, delete task. Okay, awesome. So the delete task is working. So now the next thing we want to do is, so since we're making an accessible program, if we have a bunch of tasks. Now, if a user is using the keyboard to navigate our program and it deletes the task, the focus disappears. And the focus is, you see this orange ring around the button? This is called a focus ring, or a focus as well. Now, the problem is that focus is very difficult, and users using the keyboard to navigate the site, or keyboard and a screen will rely on the focus a lot in order to tell them where they are. And if the focus suddenly disappears, it's very bad user experience and very bad for accessibility. And we have a couple of options what to do with the focus once we delete the task, because when you delete a task, the focus disappears since you destroy the element. And to do that, what I have decided is to just focus the heading. This is why we give the heading a tab index of -1, because right now if I press tab, I don't land on the heading, I land on the input element, because the input element is interactive. So what I have to do now is I have to move the focus to the heading. So we have captured the heading in our constant right here. So what I want to do is, once the user deletes a task, I want the focus moved to the heading. So I'm going to create another function, and I'm going to call it move focus. And it's just going to be very straightforward. Move focus, element dot focus, okay? And we want to move the focus right after we delete the task. So we're going to say move focus, and we're going to say heading. Now let's see if that works. Okay, let's delete this task, and there we go. Now the task is deleted and the focus is moved to the heading. You also have the option of moving the focus at the first element of our task list. I mean, I think it's like personal preference. I prefer to move it in the heading, but maybe in time I will find other ways to move it. But focus management is very tricky, and this is just the best I can come up with. Okay, so let's see what other what other function we have to put. Okay, so we have deleted our task, and if we are sighted, we can see when a task has been deleted because it disappears. But if you're using a screen reader and you're blind or visually impaired, this is not going to be obvious to you. So what we have to do is use our trusted area live legend, and we want to task it to instruct the screen reader that the task has been removed. And to do that, what we're going to do is we're going to use our get screen reader feedback function we defined earlier, and we're just going to copy it, and we're going to make it say stuff. So I'm going to make it say the first argument is going to be task name, and the second is going to be removed. So the first argument is going to say the name of the task, and the second is going to say removed. Okay, so let's see if that works. Let's add some more tasks. Okay, and I'm going to use the keyboard to delete a task. So let's delete this FDA task. There you go. The live region says it's removed, and this is going to be communicated to the screen reader. And this is excellent. This is what we want, since remember, users using screen readers are more likely to be blind or visually impaired, and actions we take for granted or feedback we take for granted since we're sighted, it's not going to be obvious to them. So this is the end of our little program. It's accessible. I can navigate it with my handy keyboard. I can select and check the checkboxes. I can delete tasks. I have focus control. I have screen reader feedback. I tested this on my screen readers. I tested this on JAW, NVDA, VoiceOver. I think I also tested it on TalkBack as well. So whenever you finish creating an accessible program, or even during development, if you're not sure if a certain feature, most probably area, is not going to be supported by a screen reader, test it on a screen reader just to make sure. So this is it. This is how you create an accessible to-do list app with JavaScript.